Hello, good morning. How everybody doing? Good afternoon. Um, so welcome back. This is just a video to kind of get the kinks out. We didn't have homework over the break, so really this is just to kind of review just basic fundamentals of mechanical engineering, and it's called mechanics. Now, mechanics are very important, but sometimes they don't seem like that, but they're very important. They're just the fundamentals of being a mechanical engineer. And when you're talking about fundamentals, you're talking about the basic skills needed to do the job. Basic skills, meaning that the very first things you need to do in order to do this job effectively. So, fundamentals of mechanics analogy would be like if you're a basketball player, a fundamental of that would be shooting a free throw. Okay, if you want to play basketball, you have to know how to do that. Or, say for example, you are some type of mechanic and you fix cars, mechanical engineer. You're some type of mechanic and you will need to know how to change a tire. Like that's just the basic skill you need to know. Or if you're a doctor, you need to know how to give a patient a shot. And so mechanics are just fundamentals for being a mechanical engineer. And when you're talking about mechanics, you're talking about the following. You're talking about metric and US customary conversions. And that's just knowing how to convert between different type of units based off of the situation. Okay. And this is very important because you'll find that as you travel throughout the world, different people, different countries use different units. Okay. And we want to figure out just how to convert, and it's just a skill you need to know. Okay. Secondly, you need to know geometry. You need to know how to measure using the US customary metric units, the shape of stuff or how it looks. In our case, we've been talking about area, perimeter, and volume of a square or a rectangular prism because that's the shape, that's the object of the robot chassis that we're working with. And then you need to know more of the mechanics. Specifically, we're talking about the motion of the object or how it moves or 1D motion. And what I mean by 1D motion, I'm talking about if I have a robot and I know its geometry, I know how it looks, I know the metric unit conversions, I know the shapes. Okay. I also want to know how fast it is, right? I want to know its speed or velocity. I want to know how far it can go, the distance that it takes, the time that it takes for it to go or move. I want to know its acceleration. How much force is that car providing or using? Okay. And so today we're going to talk about just how to do the mathematics of STEM today. The math of those mechanics. Okay. So you're going to be doing some math today. So go ahead and open up your calculator. And we're going to go ahead and get started. So I'm going to show you a couple examples of just how to do the basic stuff, and then I'm going to focus more on the speed problems, just so you can get a hand idea of what they're asking you to do. All right. So the first problem we're going to do is number 1 and 2. Okay. Now, when you're doing these problems, you always want to write out the ladder. You already have the ladder provided. Deci, centi, milli, deca, hecto, kilo. Okay. And number 1 says convert 35 meters into kilometers. And I know that this is a metric unit conversion because they have the same base. And that base is meters. So when I do the problem, I'm going to go to meters, and I know that meters is going to be here. Meters is m by itself. Kilometer is m to the right. Okay, if m by itself, then that means it's meters at the base. Okay, and I'm going to this call kilo. That kilo prefix, so that's this prefix here. So I'm going from the base to kilo, and I'm going to count. I start counting after my first step. 1, 2, 3. And then I count for the direction that I went, and that direction was to the left. So that means that I'm going to move 3 steps to the left with the decimal. And the decimal of the number, if it doesn't have a decimal present, hold on. The decimal of the number, if it doesn't have a decimal present, is always going to be to the far right of the number. So you start here and you count 1, 2. Now, understand that if you do not have any more numbers to the left or right of you, you still finish that third spot, but you fill it in with a 0. And then that decimal is going to be to the left now because it started from the right. So the answer is going to be 35 meters equals 0.035 kilometers. Okay. All right, go ahead and try number 2 on your own. Take the next minute and do that. That's 378 grams. Is how many milligrams? I'll write the whole thing out. All right, so you first want to know that the grams is at the base, G, and grams to milli, the prefix, is the M where it's to the left, okay? So understand there's a difference. Meters is always going to be by itself. That's an M, but that's a base. That means that could be by itself. Milli has to have some type of base with it because it's a prefix. So milligram is always going to be this M here. Milli. Don't forget that. Okay, and so that is start counting after the first step. 1, excuse me. 1. I'm sorry. Let me fix this. Starting at the base, 1, 2, 3, and you went 3 steps to the right. So again, you don't have a decimal here, so you have 378, and that's going to be 3 steps to the left. You always start to the far right. 1, 2, 3. Wait, excuse me, confusing myself. I'm supposed to go to the right, not the left. And so we have 378 grams, and that's going to start to the right, and you're going to go 3 steps to the right. 1, 2, 3. And you don't have any numbers there, so you fill them in with zeros. And the decimal is going to be to the right, but if you have any numbers leading, meaning that if you have any numbers leading the zeros, so if you have, I have numbers leading the zeros, so I have it to the left. Any numbers leading the zeros, the decimal goes away, and you can just write it as 378,000 milligrams. And the decimal does not have to be there. All right, so that's how you do metric unit conversions. All right, next we're going to do U.S. customary conversions. All right, and so let's do number 20. All right, so number 20 that says 2 days to hours. All right, so we got 2 days. All right, and you know that this is a U.S. customary conversion because the units do not match. Okay, and compared to metric unit conversions, where for the problem we did here, you're going from 35 meters to kilometers. So that's 35 meters to kilometers. This is a metric unit conversion because they share the same base. All right, and so with U.S. customary conversions, you have to use a T-chart always because you have to change the units to a completely different unit. And a T-chart is this here. It's just the big old T. You're going to have 4 quadrants, meaning you have 4 spots. 1, 2, 3, 4. Okay? All right, so the first thing is nothing ever goes in 3. Okay? Nothing ever goes in 3. All right, and the goal is you want to change the unit to a different unit. So our question asks 2 days to hours. So we're going from days to hours. When you're doing a U.S. customary conversion with the T-chart, you have to have this ratio called a conversion factor. Conversion factor. Okay, and with the conversion factor, you want to pick the number with the same unit as the problem you're trying to change. What I mean by that, you want to change days to hours. So you got to look at days, and you're going to put the days in the 4 spot. And you put the number there because that's 1 day. And you put the other one at the top. And the reason why you want to do that because you want the days to cross out diagonally. In order for the days to change, you have to divide it, meaning that it has to be under it. Okay, because if you divide anything by itself, it always cancels out or goes to 1. All right, and so next, after you do that, you're going to follow the rule. If the 1, so meaning that this here, if the 1 is at top, you multiply. If the 1 is at bottom, if the 1 is at the bottom, you're going to divide. Okay, so the 1 is at the bottom, so you're going to multiply 2 times 24. So 2 times 24, 2 times 24 is, you pull out your calculator, that is 48, and it's going to be 48 hours. Okay, all right, so the next part is area, perimeter, and volume. All right, so these are really simple. All you need to do is remember the equations. Area equals length multiplied by the width. And then perimeter is going to be 2 times the length plus the width. And then the volume is going to be the length times the width times the height. Okay, and what this dimensions or geometries for is for a square or a rectangular prism. And what a rectangular prism is, just a 3D rectangle. And that is the shape of our robot. So that's why we want to know that those geometry numbers. Okay, and it's going to ask you to do it in US and metric, and we know what those are, right? All right, so the last thing we're going to do, but the video is going to go off, so I'm going to go over speed, distance, and time in the next video. Okay, all right, thank you. Goodbye.